And finally, the last two examples. Take a moment to look and see how these are different from the last example. Think to yourself, feel free to pause it. What we notice here is that we're trying to find the angle, where previously we were trying to find the side. That's fine. I'm still going to set everything up the same way. I'm going to circle the angle, but I'm circling the angle I want to find. I'm going to label the hypotenuse. And then the root 2, is that opposite or adjacent from the angle that I circled? Is it across from the angle that I circled or beside it? It's right beside it, so I'm going to call it the adjacent. Okay, so I have hypotenuse and adjacent labeled. That means I'm going to use cosine. Remember, we know that cosine of an angle is equal to adjacent over hypotenuse. So I have cosine of the angle. Well, I don't know the angle, so I'll keep it as theta, equals adjacent, which is root 2, over hypotenuse, which is 3. I should be able to end solve this as well. That actually might not be a good idea. You could end solve it, but it's not always going to give a correct answer. We'll see in maybe the next question why not, I think. So my advice for this one would be, rather than to end solve it, to get theta by itself, we use what's called the cosine inverse. So to undo the cosine, to unwrap the cosine from the theta, we use cosine inverse of root 2 over 3. Cosine inverse of root 2 over 3. And then we get theta equals, let's see, to find cosine inverse, we go here, cosine inverse of square root of 2 over 3. Oh, sorry, I need to control enter. There we go. So it should be 61.87 degrees. 61.87, it says correct to the nearest degree. So 62 degrees to the nearest degree. Now, if I went back here and tried to end solve, I think it will work, but it won't always work. Let's just make sure. So end solve, I have cosine of x, I'm going to call it x, equals root 2 over 3 comma x, and I get the same answer. Great. So it did work. Now let's see what happens for the next one. I'm also looking for an angle, so I'm going to circle the angle. I still label my hypotenuse, even though it's not really needed here. It's not given, and I'm not trying to find it. But it still, actually, I think it helps me determine what opposite and adjacent are. So then I look at the angle, and what's opposite the angle, and what's beside or adjacent to the angle that's circled. So hypotenuse is not helpful because I'm not given it, nor do I need to find it, but I do know the opposite and adjacent. So look above, which trig ratio uses opposite and adjacent, and it's tangent. So I know tangent of the angle is equal to opposite over adjacent. I'm just going to write that out first. Tangent of the angle equals opposite over adjacent. So that means that tangent of theta equals opposite, which is 8, over adjacent, which is root 7. Let's see what would happen if I try to end solve this. Tangent of x equals 8 divided by the square root of 7. It did work, so maybe it will always work. I get 71.7 degrees. Great. I do get 71.7 degrees. Good. Actually, it will always work. Yeah, end solve will always work here. Okay. I'm losing my mind. End solve will always work. But the other way that you've learned in the past to solve this is that you could also say theta is inverse tangent of 8 over root 7 in the calculator. And you can find inverse tangent as tan -1 is what we call it. Either way, you could also end solve it, which will work. for, at least for right triangles, and that's 71.7 degrees. 71 point, oh wait, it wanted the nearest degree, so we have 72 degrees. And that is it. Thank you.